Hello and welcome to this video on solving linear equations. A linear equation takes the form of y equals mx plus c, where this m value and this c value are different numbers. Generally, you'll be given a linear equation that may look like either y equals, there'll be a number here, let's say 2, you'll have the x, and then there'll be another number, and it could be a positive or a negative, let's say negative 3. So y equals 2x take 3. In this case, our m value is 2, and our c value is negative 3. So that's how linear equations work, that's how they look. To solve a linear equation, they usually give you a value here at the start. Instead of y, they will give you a value. Perhaps they'll give you the value of 3. Perhaps they'll give you the value of 3. So they will write 3 equals 2x take 3. To solve this linear equation, we want to find what this x value needs to be for 2 times x minus 3 to equal that value, 3, this value at the front. What does that x value need to be for 2x take 3 to equal 3? That is what it means by solving a linear equation. You have this linear equation, 3 equals 2x take 3, and you need to solve it, finding what this x value is, finding what that x value is for this to be true. The first thing I want to show you is the rule of opposites. I like to call it the rule of opposites. The rule of opposites relates specifically to our operations. We have plus, we have minus, we have multiplication, and we have divide. And this is saying that these operations have an opposite operation, an operation that is performing the opposite of that. So for plus, our opposite is minus. For minus, our opposite is plus. For multiplication, our opposite is divide. And for divide, our opposite is multiplication. So these two here are opposites, and these two here are opposites. This is what we use when we are solving linear equations. Let me show you with this equation. 3 equals 2x minus 3. We want to find what x equals. To find what x equals, we want it to be on its own. We want this x to be isolated on its own on one side of the equation. To do that, we move these individual terms. So we've got a term here, which is negative 3. We've got a term here, which is 2. We need to move these to the other side of the equation. We need to move them over to the other side of the equation so that this x is on its own. I'm going to start with this negative 3 here. This 3 is minusing. There's a minus there, the 3 is minusing. When we move things to the other side of the equation, we need to put the opposite operation. So the opposite of this negative here is plus. There's our opposite. So I will write 3, that's where we started with 3, plus 3. 3 plus 3. So I've taken this negative 3 here, I've moved it over here, and we have 3 plus 3. This equals 2x. So that is staying the same. 3 plus 3 equals 2x. This equation is still the same. We have not changed anything about it. We have just moved our negative 3 over to the other side. We have kept it true by reversing that operation. So now we can answer this and continue. 3 plus 3 equals what? Well, 3 plus 3 is 6. 6 equals 2x. Now, as I said before, we want to isolate this x. So we want to take this 2 and we want to move it over there. We want to move it to the other side of our equation. To move it to the other side of our equation, we need to reverse or write the opposite of its current operation. Now this 2, it is a positive 2, but it isn't plussing. They are that There's a difference there. This is a positive 2, but it isn't plussing. What is this 2 and the x doing together? What is that operation in between? Hopefully you know that in between this 2 and the x is a little multiplication sign. So it is multiplying with the x. When we move it over, we need to do the opposite. What is the opposite of multiplication? Here it is. The opposite is division. So when we write this out, we go 6, because that's what we have. We keep our 6, divided by 2. 6 divided by 2. And that equals x. Just on its own. We have got x on its own now. 6 divided by 2 equals x. Well, what is 6 divided by 2? Well, half of 6 is 3. So 3. 3 equals x. So now we know x equals 3. If 3 equals x, then x equals 3. We can do another test with this. So I'm going to take my initial linear equation, I'm going to bring it down and I'm going to write it down here. 3 equals 2x take 3. But now I'm going to write it and I'm going to put my value for x. What does x equal? X equals 3. What is the 2 and the x doing? They are multiplying. So I will write 2 times 3 minus 3. Now just look at this bit for a second. Just look at this bit and see if we can work this out. 2 times 3. What is 2 times 3? Well, 2 times 3 is 6. 2 times 3 is 6 minus 3. I'm bringing that minus 3 down. What is 6 minus 3? 6 minus 3 is 3. So we've got 3 here and we've got 3 here. So this is true. 3x equals 3. That is true. So for this particular linear equation where we have 3 equals 2x minus 3, x is equal to 3. Sometimes you'll get linear equations that look like this. Sometimes you'll get 4x minus 2 equals 10. Sometimes you'll get ones look like that. 4x minus 2 equals 10. Again, to solve this, we want to isolate this x value on its own so that we can find what that x value is for this what that x value is for this equation to be true. We work with the rule of opposites again. So I will take, I've got this term here, I've got this term here. I will take this term and we will move that term over. This term is a minus. The opposite of minus is plus. So I will write 4x, because we're moving this term over, so we're left with 4x on there, is 10 plus 2. What is 10 plus 2? Well, 4x equals 12. 10 plus 2 is 12. Now I've got this term here that I want to move over. What is the 4 and the x? What is the operation between the 4 and the x? It's a little multiplication. What is the opposite of multiplication? It is division. So when I move this 4 over, we can write, x equals 12 divided by 4. If you'd like to use your calculator, you can do that. X equals, what is 12 divided by 4? 12 divided by 4 is 3. Coincidentally, this answer is the same as the last one. It's not always going to be 3, but this answer is 3. Looking back to our original equation here, 4 times 3 equals 12. 12 minus 2 is equal to 10. So this is correct. X does equal 3. That is correct. x is equal to 3. Here's another one here. 7x plus 2 equals 2. Once again, we want to isolate this x value so that we can find out what it equals for this to be true. We have got a term here with the x value. We've got a term here with the x value. We start with our plus and our minuses, and then we do our multiplications and divisions. So our plus 2 comes over here. What is the opposite of plus? The opposite of plus is minus. So when we move it over, we have got 7x equals 2 minus 2. So 7x equals 0. 2 minus 2 is 0. Now we have got this 7 that we need to move over. The 7, once again, is multiplying with the x. The opposite of multiplication is division. So we want to move that over. So we want x is equal to 0 divided by 7. 0 divided by 7 is equal to 0. This question looks a little bit more complicated, but if we follow the same rule of opposites and the same process, it's just as easy. For example, we know that we want to keep x isolated, so we want to move everything else to the other side. Start with our negative 2 here. We want to move our negative 2 to the other side. What does negative 2 become when it goes to the other side? It becomes positive 2. It becomes positive 2 over here. So we're left with, so on the left side of the equals sign, we have x over 4, or x divided by 4. And on the right side, we have 3 plus 2. So x divided by 4 is equal to 5. 3 plus 2 equals 5. Now we have this 4. We have this 4 here. What is this 4 doing? What operation is this 4 performing? Well, this 4 is performing a division. It's dividing. So when we move this 4 over to the other side, the opposite of divide is multiply. The opposite of divide is multiply. So we multiply by 4. So we have x equals 5 times 4. What is 5 times 4? Well, 5 times 4 is 20. So x equals 20. For this linear equation here, x over 4 minus 2 equals 3, x is equal to 20, for that to be true. This is the final question that I'll do, and this one is a difficult question. This question is difficult to wrap your head around what exactly to do, but once you know what to do, it's the same for all questions like this. So once you know how to do one or two of these, I'm fairly confident that you'll be able to do any question like this. As before, we want to isolate these x values here. We want to isolate these x's. However, we want to isolate them all on one side. So we want that x to go onto that side there. So the first thing we want to do is move that x over to the left-hand side. When we move it, we need to do the opposite. So currently, this x here is a positive. It's a positive x. So when we move it over, it will become a negative. So we can write 3x minus 2 take x equals 2. So now on the left side of our equation, we've got our negative x and we have our 3x, which is great. But we do have this negative 2 here that we don't want. We want that negative 2 to be moved over there. So we can do that. However, we need to remember the rule of opposites. So this negative 2, the opposite of negative, is a plus. So that negative 2 moves over and becomes a plus 2. So 3x take x equals 2 plus 2. So we've moved that positive 2 from the left side to the right side. We've got 3x take x on the left, and we've got 2 plus 2 on the right. 3x minus 1x. We've got 3x here, and we're minusing 1x here. 3x minus 1x is the same as 2x. 3x minus 1x is 2x. 2 plus 2 is 4. So 2x equals 4. Now the final step, we've got this 2 here with this x that we don't want. We want to move this 2 over. What operation is the 2 performing on the left here? It is performing a multiplication. So when we move it over, we will do a division. So we can write x equals 4 divided by 2. We're doing that division. We're moving that 2 over to the other side and dividing it. Therefore, x equals 2. 4 divided by 2 is 2. So x equals 2. That is all on solving linear equations. I hope after the explanation and watching these 4 practice questions, you have a bit better understanding on how to solve these questions yourself.